welcome to the webinar, 10 Secrets for Tire Pyrolysis Technology Selection. I will share my screen for the presentation. Honestly, my goal for today is that I want to show you that there is actually a lot of non-technical items to technology selection. So we have a straightforward agenda. I'll do a quick introduction about myself. We'll also look at who is attending today. I will do a short overview on technologies, and then we go secret by secret. I have two bonus items, and you will see actually at which place the actual technology comes. And then we'll do questions and answers. So first, I start with you, not with me. We have today three pyrolysis technology companies in the webinar. We got EcoTR from Chile. We got Carlton Forest from the UK, and we got WF Recycle Tech from the UK as well. And linked to WF Recycle Tech, we should have Farrell Pomini, but I haven't seen Farrell Pomini in the Zoom yet. Maybe they're watching just on the website. Who am I? I'm really working on recovered carbon black. That is really my passion, and also on tire-to-tire recycling, and that really governs everything I say I do for tire-to-tire recycling, because I think that's the only market big enough to put the tires back, both with recovered carbon black, with tire pyrolysis oil. I've also worked on alternative carbon blacks. The last two conference presentations you might have seen, or yesterday I had a live with Cabot, were on alternative carbon blacks, including but not only recovered carbon black. I'm the founder of the Smithers Recovered Carbon Black Conference in 2019, working with many recovered carbon black producers, also big companies like Decathlon, Michelin, BASF, Bridgestone, Hutchinson, and many more. I'm also a coach because I realized that technology doesn't change the world, but humans who apply technology. So many of the challenges we have are of human nature rather than technology and nature. My last passion includes video production for LinkedIn and YouTube, but I'm also doing a documentary on recovered carbon black this year and next year. My background, chemical engineering, titanium dioxide, custom color master batch, and carbon black, getting closer to the topic. Now I want to give you an overview on what I see with my data on global tire pyrolysis industry. So this is from my database. I used to sell these databases, no longer doing that. I might put them on as like a database subscription on the website. I have currently 499 companies in my database. 221 are in Europe, 107 are in Asia Pacific, 98 are in North America, 49 are in Middle East Africa, 24 are in South America. So these are a lot of companies. How can we slice and dice into groups? 113 have continuous technology, 101 discontinuous and batch technology. 5 are refining companies. The UK colleagues in this webinar surely know Waverley Carbon. That is, to my knowledge, one or the only European recovered carbon black refining company. Now it gets interesting because we have 239 operators, which means these are companies that maybe apply somebody else's technology. And we have 154 technology providers. We got 93 technology providers that also have their own operation, and I will get to that topic in a moment. Then when we further slice and dice and we put some filters on, I would say really of all those companies, I personally would put up a short list of maybe 18 companies globally that I tend to use in a short list when clients ask me for a technology selection. And actually, we could do this as a workshop. You could put all my criteria on in one column, and you could put in one row the company names, and then you can do something like high, medium, low. We can do a kind of traffic-like thing. This is typically what I do at the start of a deep consulting project, which typically, of course, is like 100 times more expensive than this webinar. Clear to say, there is no universally best technology supplier, and I will tell you with all these criteria. However, of course, there will, for every use case, for every investor who wants to have a tyre pyrolysis technology, there will be one ideal technology supplier for that situation, for that person, for that geography, for that kind of end-of-life tyre feedstock. And that, of course, is the whole goal when people do technology selection. Secret number one, maybe you know me, I'm always starting with people. Why? Well, we don't really have investor people in here. We mainly have experts of the technology themselves. But imagine if you spend millions of euros on tyre pyrolysis technology, it doesn't work as you would expect. And honestly, the chance for that is very high. Even all the top companies, they haven't really fully industrialized. So the chance is high that things go pear-shaped, things go wrong, and things have to be corrected. And then the make or break question is, would your supplier help you to get it right? Maybe even no matter what. And that is the big question. And that is where many suppliers would hit the wall. Because let's say Chinese suppliers are machine suppliers. They're not really known for service and after-sales service. So the right partnership really enables everything. And that is because we are not in a business-to-business industry. We are in a human-to-human industry. We need trust. We need the relationship. We need the ease of business. I personally like really business which is also enjoyable and where I really get inspired by my business partners. So maybe that could be a deeper purpose and vision. People that are like me, maybe people that run or maybe do triathlon. So I like that kind of relationship. Also, what are investors purchasing? Are they just purchasing a machine, a technology? Do they purchase service? Do they purchase a partnership? Because as a technology supplier, maybe you have other collaborations. In this webinar, WF Recycle with HF Mixing Group, including Ferrol Parmini. That is a nice partnership, and a licensee could actually benefit and collateral of that kind of partnership. Other technology suppliers might have other partnerships their licensees can benefit with. And of course, the goal is if the relationship is right, the service is right, you do a copy and paste. You do a long-term partnership, maybe in different geographies. Maybe you increase the capacity on site. Secret number two, it really is important. I've seen very, very few investors and potential licensees who really configure the whole plant themselves. They want a turnkey system. And the problem actually starts when we ask Google for a pyrolysis plant. We receive only about the pyrolysis reactor. And specifically, again, I don't want to bash Chinese companies, but maybe it's lost in translation. Typically, Chinese companies call their reactor a plant, which of course it isn't. And I'll go deeper on that in a moment. So that is not very helpful if you only have the reactor. It will be the start of a journey, of a very tedious journey with a lot of challenges if you don't have the whole plant. typically financial people, investors, they don't even understand what is carbon black. They don't understand the difference between carbon black and recovered carbon black. They don't know what end-of-life tires consists of. They don't know the markets. You can only know so much. If you bring the money, you can't be accepted to know all the complexities of a recovered carbon black production. And let me get into recovered carbon black production as the deeper example. So this is a slide many of you might have seen. I put this in many presentations just to show what is the recovered carbon black composition, and also where do we control which element of the composition. I have an added element here. This is from the ASTM definition. The green is from furnace carbon black definition, and the yellow is from the recovered carbon black definition. Clear to say, we have feedstock depending, actually the larger part of the composition of recovered carbon black, because the mixture of real carbon blacks coming from the tire we are recovering or reclaiming, as Cabot says, for example, is 72 to 82%. So this is the major piece, and this is the workhorse, the only functional piece we have in the recovered carbon black. It does not depend on the pyrolysis. It depends on the selection of the end-of-life tire feedstock. The same as the payload. I call it the inorganics because it is only ash when you burn the organic part. So ash for me is the wrong technical term. Of course, the ash content depends also on the feedstock. European tires have high silica content. We know the story. So again, pyrolysis cannot help us at all, and the technology cannot help us at all getting a lower ash content. But we need to select the feedstock. Then, what can the pyrolysis do? The pyrolysis hopefully will provide us a dry recovered carbon black with close to zero volatile hydrocarbons, close to zero PAH content. And hopefully, but this is really the difficult part of it, hopefully also with zero carbonaceous residues. Zero is not really possible, but as low as possible, so that the carbonaceous residues, the fresh carbon coming from carbonization of the polymer, do not inactivate our carbon blacks and block them on the surface, which then would lead to poor rubber reinforcement. So you see, really key elements of the recovered carbon black position don't come from the pyrolysis. They come from something up front. And just a little tidbit, this year, really, I think we might be able, and ASTM might be able to nail the classification system for recovered carbon black. We have all the analysis methods we need. There's one missing, which is the particle size, which could measure the dispersion, because everything that is not dispersed in the rubber cannot do its work. So particle size is crucial for good in rubber dispersion. Of course, so is granulating or pelletizing, because if we put the powder in a rubber mixer, it could be that we lose much of the powder, actually a large fraction of the powder, by the degassing when the internal mixer is degassed. And that was specifically mentioned to me by Pirelli, for example. So they don't accept any fluffy. They only accept pelleted carbon black and pelleted recovered carbon black. And you can see the mixture of carbon blacks, I think, can be best determined by the in-rubber performance, by the Fourier transformation rheology. So how much can the green rubber be reinforced? We always need to have a benchmark with that, maybe a 660 for a very good recovered carbon black, or a 772 for a less good recovered carbon black. Ash content, straightforward. There's furnace carbon black method. We can also use the TGA method for recovered carbon black. Volatile hydrocarbons, again, we can use TGA, or we can use the tolerant transmittance, which is a nice quick test, which works very well, and we're looking for more than 80. But for really good recovered carbon black, I would expect more than 90% transmission. And then again, how can we detect the elemental carbon that is added in the pyrolysis by carbonization? Again, I would say in-rubber performance is a good indicator for that. So we have all the test methods. What we said now is we're not only looking at the pyrolysis, but we're looking at the pre-processing the elt selection and elt granulation, and we're looking at the post-processing, the milling and the granulation. And everything is required. You cannot let go on one of these processes in order to have a good recovered carbon black, because the mixture of carbon blacks and the inorganic content is made by the elt end-of-life tire selection. The pyrolysis determines the organic volatiles, hopefully low, and the low content of carbonaceous residues, while the post-processing milling and granulation provides the ease of dispersion and the ease of use. Also for recovered carbon black manufacture, if you don't pellet, you need to put 2 trucks on the road for the same mass of recovered carbon black. So it has also cost and supply chain elements. And again, why do we need to select the end-of-life tire feedstock? This is a comparison between European car tires and European truck tires, and you see the fundamentally different composition. One big element is the silica, which is in the car tires, not in the truck tires. Don't deepen on that. But so the actual process we're looking at is going far beyond the pyrolysis, which means that any investor, anybody wanting to buy and license a technology from a tire pyrolysis technology provider, they look at this. They don't look at only at the pyrolysis part of the larger process. And again, this is from the ASTM definitions. We're talking about an engineered material, and how can we expect? Usually, I tell the ferry, ferry of the gold donkey. We cannot expect our tire pyrolysis kiln to be a gold donkey, where we put no matter low quality material in, and we can expect gold to come out. So this is just to show the complexity. Whole turnkey plant is very important. There are only a few possible situations where I think investors might want to do everything themselves. And this is if they have a lot of time, a lot of money, a lot of in-house engineering capability. They will also require industry advisors. I mean, I like investors who tell me, okay, they don't want to go for the turnkey plant, but I need to help them to select the mill, to select the pyrolysis, to actually do everything. That's a good project for me, but for them, it will be quite tedious. It will take time. It will take money. Also, the more specific requirements, maybe then we cannot have an off-the-shelf turnkey plant, and we need more tailoring by the technology supplier. Maybe, for example, I know a company who wants to license a technology, and then with the recovered carbon black, they only want to go in inks. Now for that requires product development, to which we get later on, for inks. You can't just use any technology. You need to be really specific from the tire selection, the pyrolysis, but also ultrafine, beyond ultrafine milling. Jet mill will be a must for that kind of project. Also, if your investor is not able to share with you as a technology provider everything he wants and his motivation, if there are confidentiality issues, then okay, they have to do the whole job, and they cannot expect from the technology supplier to deliver a whole turnkey plant. Secret number 3, external EPCC service. And that, I think, has been a game changer for tire pyrolysis technology providers. Examples are companies that are in the petrochemical area, for example, Proman. They're both an engineering company, EPC company, but they're also one of the 5 big methane producers. And Technip is a very well-known petrochemical engineering company, and both have specific partnerships with tire pyrolysis companies. Actually, interestingly, Technip not with a technology supplier, but with an investor and an operator company. So what is EPCC? We're talking about engineering, procurement, construction, and commissioning. The engineering, you might know, even before you have an industrial plant for the permits, you need a pre-engineering study, which can estimate the types of emission, the types of waste arising from such an installation. That can already cost millions. And it's very difficult to do that in-house for technology suppliers unless you have the capability to. We get to that point a little bit later. So these EPCC companies, they have hundreds of engineers. They know regulations. They can do that. They can do the full engineering. They buy the material. Also economy of scale. Here they buy a lot of steel. Maybe the steel is a little bit cheaper than when a small company buys. They have different sources. They construct it. Now with many EPC companies being petrochemical companies, they know how to construct these kind of plants. Then they would do the cold commissioning, the warm commissioning. Once everything works and the performance which has been defined is achieved, they can hand over the key. There's one step further, that would be an EPCCM service, where actually they operate the plant as well for the investor. But that is actually not what I find important in the technology selection. EPC service or EPCC service is already a brilliant service. And you see, it's again a soft factor. It's not really a technical factor. Why is that so good? EPC, external EPCC. The investor can minimize the risk. So there's an external technology, objective technology approval. But also, let's say the technology provider is located in the UK, as some of you might be able to relate to, but you have your licensee in Australia or in Japan. And you don't have anybody local in Japan and Australia. This EPC company maybe has an office there, maybe knows the local regulations for the permits, and that can be incredibly helpful. Also, EPCC companies can give performance warranties, and that's what the investor wants. If they spend millions and millions, they want to know that their investment is safe. Now, the funny part of it, now we talk about the internal EPCC service and why that could be of interest. I've seen actually only one company that has done that, but maybe there's other companies who have these capabilities as well. Specifically, these companies who are building their own technology. And they have the capability to construct in-house, and they can engineer solutions. They can do slight modifications for every customer and use case. And also they can further the technology. They can future-proof the technology. And one element that would come to my mind is if previously a kiln had been heated by gas, I see a clear future trend to electrically heated kilns. Why? Because then you can source green power and you can be close to net zero emissions, even for the pyrolysis step. And that kind of engineering, if you can do it in-house, I think that is brilliant. Also, you have some independency of the external EPC company, because sometimes when you work like in the threesome, in a triangle, communication is very difficult. If you have three parties, contracting with three companies is very, very difficult. So you have a more direct collaboration with your licensee or investor when you have the internal EPC service. And I could see a use case where maybe within the region companies do the EPC service themselves, and for on a different continent, example Japan or Australia, they would use an external EPC company. And also you can do the internal EPC once you had external proof generally of your concept. Then you can internalize again the EPC service. Also, this kind of capability you could offer a service to your peer companies. As of now, I still don't see there's much competition in tyre pyrolysis and recovered carbon black. Many companies have problems. Some have solutions to problems others don't have. So actually helping other companies, that could really advance the industry. And we're talking again about service, not so much about the technology. Secret number 5, again, non-technical, and I've seen many providers offering insurance. I think that's a clever thing. The quote of a friend and client of mine, insure everything, there's a spelling mistake, insure everything you cannot control. That client actually is a banker, and bankers, of course, they want 100%, if not 200% control. And there's two insurances that are of specific interest in our industry. The one is IP insurance. You can see the chart which shows the proliferation of tire pyrolysis patents, and it's a real minefield. I'm not a patent attorney, but I looked a lot at patents, and I can tell you there's so many patents that are, in my opinion, overlapping. Also, patents are used in a strategical way, where companies try to block others out of their technology, and it's very difficult to manage. So what happens if you have licensed your technology, which you think has a patent and is safe, but your patent is being disputed? At that moment, your licensee, your investor, needs to stop the operation of their plant. And of course, they will occur a loss of revenue and quite high loss of revenue. And it will be a huge problem. The same if they have to stop for technical reasons. Let's say the plant is breaking, and the plant is breaking after the EPC company warranty period. Then, of course, it's a difficult situation. We're talking about a Nessian technology. We don't know. We can maybe know up to 98%, but the last 2% are wildcards. We don't know if technology will last 5, 10, 20 years. Very few companies will be able to predict that. Again, big loss occurring by stopping the stream of revenues from recovered carbon black and oil. Insurance that can cover that kind of loss is great. Second reason, that which actually I didn't put on here on that slide, is some of these insurances are bankable, meaning that if you or your licensee have that kind of insurance, it's easier for them to get money because it's a risk mitigation strategy. Secret number 6, product development. And again, it's technical, but it's not talking about the actual machine for tire pyrolysis. I'm using the stage of product development of a technology provider that is also operating themselves as a degree on how far they are, how progressed they are in the industry, and how serious they are. Because no technology provider can expect from their licensees or investors that they do the whole marketing and product development piece themselves. What kind of products can we sell? So from the granulation of and the end of life tire selection, actually we can have tire cord, we can have steel. But if you do your granulation in-house, actually you might be able to sell tires that are still good. Maybe to remote locations like Africa. I know a couple of companies that do that. So when you do the tire selection, you will have whole tires you can resell, or you can have tire materials as tire cord and tire steel. I've seen Teijin Aramid very interested in recovering and separating from the tire cord, the textile, the aramid fibers that are in the high performance tires. Tire pyrolysis oil. This is the obvious thing, and in some parts of the world this is the main and the only product. Let's say Asia, China, India, Pakistan, South America, Africa. Very few companies have developed recovered carbon black products. They're only looking after the oil. But here we're talking about a different paradigm. Are we in a recycling paradigm, or are we in a engineered product sustainability paradigm? Recovered carbon black. You might know my specifications, RCB1 and RCB2, RCB1 being the state of art, RCB2 like a second degree, and I place the RCB1 can be on eye level with the rubber performance of a 600 grade carbon black, and the RCB2 maybe with a 700 grade carbon black. The 500 grade still is very difficult, and I think we can only do blends in that kind of rubber application. Tyre pyrolysis gas. So the gas usually is used for providing the energy for the pyrolysis. Of course, if we have electric heating, then maybe we have a generator, we make our own power. Or if we source the energy externally, we need to do something with the gas. But if we have our own heating with the pyrolysis gas, in order not to destruct the burners, we need to get rid of the C4 and C5 stream, which is a nice product, but you don't really read about it, you don't really hear about it, and you have two other products that nobody has talked about now. Why? Because very few companies are really at the industrial stage where you occur this kind of streams of products. For example, one is you don't want particles, solid particles in the gas. So you will have something like an aerocyclone, you will have sludge, which are particles of recovered carbon black with oil that you have to separate from the gas stream. You might have, if you do distillation of your oil, you might have a reboiler sludge, which is the very, very heavy fraction, also containing solids. And you have to commercialize all these streams, with the big streams, of course, being the oil and the recovered carbon black. So, and again, product development is a nice indication of how far and how mindful technology suppliers are in helping and making business easy for their licensees and investors. Pyrolysis mass balance, secret number 7. And you might wonder, are there secrets? I'm sharing the secrets, but these are secrets because I think not many people think of all these aspects of technology selection in that way. So therefore I call them secrets. Why is the pyrolysis mass balance important? One way of judging a technology supplier is that you do just Excel spreadsheet like I indicated in the image. You do the CapEx, the OpEx, and the revenue streams, and then you can calculate the profit, the return on investment. You can calculate the year's payback, the internal rate of return, the net present value, all the financial key performance indicators investors and financial people use to say, is that an attractive business, yes or not? I remember when I was, years back at ICI, payback time had to be 1 year. That would be a dream. I think everybody today would be happy with 4 years payback. So objectives change over time. But the key attention I want to draw here is the revenue streams, which are really the cash flow coming in from the operation. They depend heavily on the mass balance. And the mass balance, again, depends on technical things, again, like how efficient is your reactor in the heat transfer. Rubber is an insulator. It's really very, very difficult to heat rubber. And so the efficiency of heating rubber is key for the process efficiency. Temperature, of course, I've seen, anything very low temperature. And here clearly, we have to admit that the mass balance, we have a conflict of interest between the different products. And we get to that in a moment. But the oil needs different process conditions, different process window than the recovered carbon black. For the oil, it would be nice to have a low temperature pyrolysis, but then our recovered carbon black has high volatiles. So we have seen actually, and with the development of recovered carbon black and the higher price for recovered carbon black than we can get for tyre pyrolysis oil, the attention of the operation window has shifted from lower to higher temperatures. Now at the extreme end, if you operate at 800 degrees, you have very little oil. And that can be very detrimental for your oil revenue stream if you cannot valorize the gas stream. To the very extreme end, if you operate a pyrolysis close to a gasification, we only have gas and solid. I haven't seen actually analysis of the carbonaceous residues for gasification. I think the halfway house is the optimum process condition, some 500-600 degrees Celsius. But again, it depends on the pyrolysis reactor as well. Residence time is a factor as well. If we have a too long residence time, carbonaceous residues increase. Also, the end-of-life tire granulate size. There's a trend to smaller and smaller granule size to increase the surface area and to increase actually to speed up the decomposition process. But a simplified mass balance could be oil, half 50%, recovered carbon black, some 40%, gas 10%. Recovered carbon black will not change a lot. It will add a couple of single percent of char or carbonaceous residues. The big mass balance changes are really between the oil and the gas, meaning the condensable gas and the non-condensable gas. Here we really need some engineering, because if we want to be able to afford a high capex, then we need a good revenue stream. We also need to optimize on the OPEX. If a process has too high operational costs, that is a breakneck. I think a business can really do with a high capex, but with a high OPEX, you really limit yourself to markets that are very, very high value, which I have observed with a European company that is specializing in recovered carbon black for paints and inks, where the prices are really like tenfold the prices of tire and rubber, and that is because the operational cost is so high. Of course, it's nice to have recovered carbon black for inks and coatings, but some other operators might enjoy a bit more flexibility in the revenue stream, flexibility in the choice of markets. Secret number 8, again a mass balance, but this is really getting into the nitty gritty, and I'm talking about the condenser mass balance. So the condenser, we said, is where we split the gas into two streams, into the oil and the gas, so the condensable gas and the non-condensable gas. Why is that important? And it's all about the sulfur. The sulfur in the tire pyrolysis oil really limits its value. And a typical sulfur content in the oil could be 2%. That will actually dictate, that is a major factor of dictating a low price for the tire pyrolysis oil. Nowadays, of course, companies like BASF, the big petrochemical companies, they need all the volumes, and they have the means of getting rid of the sulfur in their operations. However, they will negotiate a lower price for that kind of tire pyrolysis oil. So in the end, it's detrimental for the business. If we could have a condenser that tells the sulfur not to go in the oil, that would be nice. Like, for example, even if you could hit with the oil the IMO, the International Maritime Organization spec for marine diesel, which is below 0.5% sulfur, that would be the best for the tire pyrolysis oil. That would be the highest value. And you might know the marine diesel fuel is the largest oil market in the world, which also governs the specifications and the pricing of other markets like carbon black feedstock or other feedstock that go into material valorization that don't go into fuel applications. Sulfur in the tire pyrolysis gas is less of an issue. I would even say no issue. We could eliminate the sulfur after burning of the gas or before burning of the gas, or even better with a scrubber. Sulfur in the recovered carbon black is also no issue. Sometimes we have a pre-scorch. Pre-scorch is when the rubber hardens premature because there's too much sulfur in there or too much zinc oxide in there. But rubber compounders can actually adjust that by adjusting the compound. It can be corrected in the compound. Also, I think the price impact on the recovered carbon black, if we have sulfur, there's almost no impact because sulfur goes anywhere, at least in the rubber compound. So we have a big impact on sulfur in the oil, and the condenser is a little gem if we can make the condenser direct the sulfur into the gas but not the oil. Secret number 9, talking about the TRL. TRL is the technology readiness level. And here we have again a situation where many investors and even big companies say, we cannot accept any risk. I want to have a tire pyrolysis company that has TRL 9. TRL 9 is industrial. We look at the specifics of TRL in the next slide. But that is a problem. Peter Drucker, marketing guru, said every business is founded on taking a risk. So if you take no risk, you would not have any business. And you know that's a problem. Again, that's a misconception on the investor, on the licensee side. But what can we accept? What kind of TRL can we accept? So the TRLs go from 1 to 9. And with a simple traffic light scheme, I've highlighted what I think is acceptable. So I don't think the idea level is enough for a technology supplier. Concept, proof of concept, preliminary process development, detailed process development. Now it gets interesting because clearly for an investor or a licensee, it is important to see the plant and the technology running. And the more holistic is the plant, like if you have only a reactor running, that is not as good as if you had the whole plant running, producing the commercial products. That is, of course, minimizing the risk for the licensee and the investor much more. So I would argue a yellow is if you have a pilot plant in your own operation, and maybe you don't have the full plant, but at least you need to have your reactor. It needs to be able to run. People need to be able to visit that pilot plant reactor and the yet incomplete plant. The ideal situation, however, is that you have the whole plant for obvious reasons mentioned earlier. The next stage would be a demonstration plant with a full-scale engineering, still in own operation. Number 8 would be your plant is commissioned. And with plant, really, I mean not only the reactor, I mean the full plant with the tire selection, the reactor, but also the post-processing, both for the recovered carbon black and also for the oil, if desired or required. And that could be in own or external operation. That could be actually a reference plant you might have as a technology provider, but which is the full plant again. And then between 8 and 9 industrial production, we talk about if you have at least 1 year of operation and not start-stop operation, but 1 year continuous operation. Typically in a good technology, I would aim for 330 days of operation. Of course, you need to do maintenance. Maybe you want to pre-schedule maintenance. If your technology is a little bit not as stable, a little bit weaker, maybe you only get 250 days. But that, again, for the operator or for yourself, if you're the operator, would limit the revenue stream and would limit your profit. And not part of the webinar, but I've, this week, I've said it in many conferences and live streams. The cash really is a problem for tire pyrolysis recycling companies in the startup phase, where they don't have revenue streams from operation. Where does the cash come from? So that's a big problem. And how many years can tire pyrolysis technology companies sustain without being an operator if they don't have a cash flow? Lucky companies, one company here in the webinar, of course, has a main business that is not tire pyrolysis. So that's really good if companies have a cash flow engine that they can put into the tire pyrolysis department. Secret number 10. The webinar is called 10 secrets, but I have 12 secrets, so there's 2 more. Of course, what is the motivation and why is there a big run on products like tire pyrolysis, oil feedstocks, circular feedstocks, or recovered carbon black? The tire companies and the automotive companies, they really focus on sustainability, on recycled content, bio-based content, on low carbon emission products. So we're talking about green credentials. And we all know that the green credentials, they are not really transparent right now, although there might be some ISO standards for the life cycle assessments. You might know I'm not a big friend of avoidance life cycle assessments, because then you can just take a really, really bad benchmark that is not even realistic. You compare to that and you look brilliant, of course. Let's get us discussing green credentials. I'm coming back to electrical heating. I think this is a will be a future trend. We'll see more and more processes operating electrically heated. So again, if you have in-house capabilities of converting a kiln from gas fire to electrically heated, that is brilliant. That will be future-proof, because then with green electric power, you can operate very close to net zero emissions. And with green power, I mean solar and wind power. They're not net zero. There are some emissions attributed, even in scope 1, 2, and 3, but it is the best we can do. Definitely better than burning any gas or any oil for energy. So when we talk about green credentials and we talk about the emissions, this really comes down to the heat transfer efficiency. And here, my pyrolysis model is for 400 kilowatt hours per ton of end-of-life tire granulate. This is like as best as you could get. Of course, no process operates at 100% efficiency, and this is for 1% steel still in the granulate and 1% moisture. But you can look at your or your technology providers' heat requirement for 1 ton of end-of-life tire granulate, and then you can compare it to the 400 kilowatt hour per ton, and then you can calculate what is the heat transfer efficiency. As for the carbon emissions, they need to be clearly declared. So the Global Reporting Initiative, Scope 1 is direct emissions from production, Scope 2 is energy purchases, and Scope 3 is the supply chain, either upfront, upstream or downstream of your plant. Upstream is the sourcing of material, meaning end-of-life tires. If, for example, you're in India and you source your tires from the UK, then you make recovered carbon black, and then you send your recovered carbon black back to Europe, because that's the main market for sustainable product like recovered carbon black. That is, of course, not very sustainable in a type of analysis, scope 3 analysis for the supply chain, because you're moving your feedstock a long distance, and then you're moving your final product a long distance as well, and that will occur additional emissions. What can we expect from tire pyrolysis? Now, I'm attributing the emissions by the mass balance. So on the recovered carbon black, when we say it's about 40% of the mass balance, we could, for example, have some 0.5 tons per ton of recovered carbon black in scope 1, compared to a furnace carbon black of 2 tons 62. That it really is a very nice reduction. Scope 2, there's a spelling mistake. The second line should be not scope 1, but scope 2. Scope 2 is energy purchase. Actually, there's a lot of energy required by the tire pyrolysis plant. And also you might know that the pyrolysis itself is not the biggest emitter of CO2 equivalents in the whole plant, but also we mill. Milling is creating some emissions, but low emissions. The big emissions is during pelletizing, because typically recovered carbon black and carbon black are wet pelletized, so we're mixing with water, we make the pellets, and then we have 50% solids, 50% water, and we need to dry off that 50% water. And the drying of water is a very energy hungry process, which of course will occur emissions again. So in the purchase of energy, I find pretty similar values per ton of product similar to furnace carbon black. But that of course varies as to the technologies chosen and the processes chosen. Other green credentials, we have seen ISCC, EU and plus, EU being for the fuel, and this is really for the oil, and the plus is for the mass balance use. There are of course others, but I would put a question mark to these green credentials. For example, there's the EcoVadis analysis, but I need to analyze it a little bit further. Even furnace carbon black producers already have now the platinum level of sustainability, and they still have scope 1 emissions of almost 3 tons per ton of furnace carbon black. So I'm really wondering what is the use of this EcoVadis sustainability assessment. Secret number 11, and now we're getting a little bit more technical and yet not, and this is the build quality. I'm just showing you a picture of, let's say, a cheap tire pyrolysis kiln and a more elaborate tire pyrolysis kiln. Clearly, it's a economic versus ecologic approach. I will not say who is the company left or who is the company right, but the left company would operate maybe in Bangladesh on the recycling paradigm, and the right company would operate in a Western economy or Japan, which is really which has high hurdles for permits, which is operating on an engineered production approach of sustainable products. And it's clearly visible whether the pipe connections are just whacked together to work, or whether there actually is, as a chemical engineer, I find in a nice installation there is some beauty, there's some art. When you look at the pipes, it's really nice to see a well constructed plant with stainless steel with really good material built in. Secret number 12, technology type. So maybe that is the topic you initially expected when you signed on for the webinar, and maybe investors, that is their first question. Should I go continuous? Should I go batch kiln? Maybe throwing in some companies. Some companies do a lot of press releases every week. Are those the best technology? And for me, really, this kind of question is really at the end, before you have cleared all the other selection criteria I mentioned, starting again with the people. Because if the people dimension is not working for the investor, the licensee, or if the people dimension is not working for the technology supplier, because it really is, it goes both ways, right? It's not a one-way street. Then the best technology, the best project, and the biggest financial funding will not help if the people don't work out. So let's look at some aspects of technology. The question, is there a best technology type? And you might know the answer. All these people have the question mark on the forefront of the head. There, of course, is not a generic best technology type. There is a best technology for every project, for every feedstock, for every geography, for a specific type of use case. Let's look at some tire pyrolysis reactor trends. And I think really the technology, I mean, to find the diamond in the technology, we need to look at the topics I will mention. There's a trend for multi-stage. Why multi-stage? With a multi-stage pyrolysis, for example, if we do 2 rotary kilns, one after the other, the first is splitting the oil and the second is drying the recovered carbon black, we decouple the process conditions and we can maximize the mass balance and the quality of individual streams, and we can maximize the revenue, maximize the profit, and that is really what every business wants to do. Even if you're really for sustainability, you want to make the world better, you can't make that without money and without profit. So multi-stage, as easy as putting two reactors behind each other, but be careful, because that will of course occur double of the capex, double of the energy, double of the emission, double of really everything. Maybe the sweet spot therefore is the second trend I'm mentioning is the trend to auger kilns. And there are auger kilns where you have actually the kiln with several passes or flights of augers in one kiln, and then you can add very easily one or more passes of screws in the same reactor that use the same energy, thereby increasing the efficiency. Interestingly, the good news for recovered carbon black last year in the recovered carbon black conference in Berlin was we finally have a registration for recovered carbon black in Europe. Initially, it was amorphous carbon and silicon dioxide recovered from pyrolysis of spent tires. But ECHA has changed that to a two-stage pyrolysis. So that's also an indication that multi-stage is important. It actually is a topic for future technologies. If you want to, as a technology provider, future-proof your technology, you should consider multi-stage. Trend to auger kilns, mentioned already. State of the art, we had also in the Recovered Carbon Black Congress in Berlin, we had the presentation of a PhD student from the UK. Brilliant presentation showing different technologies and where they are in terms of mass flow and quality of products. And the sweet spot really was the fluidized bed. Why? Because fluidized bed has the highest thermodynamical efficiency. The only downside is there's one company, fluidized beds are maybe in every university pilot reactors for pyrolysis. You can have a fluidized bed, and there's various types of fluidized beds, but there's only one company, to my knowledge, that is developing these technologies, scaling up, and this is a company that is not licensing its technology. They want their own technology to stay within the company. Continuous, I think there is a trend and more companies are putting on continuous pyrolysis reactors rather than discontinuous. However, it requires the granulation for the end-of-life tires. We cannot put full tires in there. There are kilns that haven't really been industrialized. There's a big kiln for 63-inch mining tires. Every mining tire 4 tons, and it's a conveyor kiln, and it's a beast. But I don't think it was built yet, and I'm not sure whether this is the way. So any other continuous kiln will need a size reduction of the tires, granulation, and there's a trend for smaller granules because then the specific surface of the granules increases and the efficiency of your pyrolysis increases as well. Now there could be specific use cases. I would not say that batch kiln is not working. Maybe it's more difficult to automize with the filling and with the emptying, but companies in Scandinavia have solved that problem. The use case I would have for a batch kiln is you can potentially recycle tires that cannot go in a size reduction process, or where it is too expensive. And I have 3 examples. Self-sealing tires, luxury cars, modern SUVs, they have self-sealing tires, and there is above the inner liner there is like a gel which when a nail punches through the tire and oxygen comes in, the gel reacts and it vulcanizes so that you can continue your drive until the next garage. And unfortunately, when you shred these tires, that creates a big problem. And actually, it is not recommended to shred these kind of tires because they're all gooey and they will react in the shredder. And it will be a big problem in shredding granulation. Also, which is not coming from the huge number of end-of-life tires, but coming from industrial waste. The tire industry, as you know, has about 2% of global tire production as faulty tires that are not fulfilling these specifications. But there's also an amount of tires that haven't even been vulcanized. And the same challenge for shredding and granulation exists for green tires. If the tires haven't been vulcanized, you cannot really cut them because the compound is still gooey, is still green, and it's very difficult. It will clog the shredder. These big mining tires, I know EcoTR is specializing on these mining tire pyrolysis, but the mining tires need a lot of energy to cut down. The bead wire of a mining tire could be as thick as a leg. And so one strategy could be to pyrolyze whole mining tires. I'm not saying this is the best strategy, but certainly a size reduction of mining tires is very energy hungry. And the last one mentioned already, electrically heated, so that we can enable low carbon emissions. And that brings me to the end of the presentation and brings me to the questions. Thank you already for attending the webinar, also for people who purchased the webinar afterwards. Thank you for watching. If people have offline questions, of course, you can always send me questions by email, over LinkedIn or over my website. Two things, I have a fresh pricing brief on my website about furnace carbon black imports to Europe and recovered carbon black pricing. And I'm a little bit late with the report update prospects for recovered carbon black, which I'm doing with Notch Consulting, Paul Eiter, and we both had too many conferences this month, so that we may only publish our new report update in the month of May. So next month, not this month, because this month is already closing. So again, thank you. I will open questions and answers, but we'll do that in the normal Zoom session now.
What is the market for textile fibers from end-of-life tires?
So, I mean, I think this has to be developed. There's no, I would say there's less demand or less progress and development of that kind of product and market as for recovered carbon black. That's very clear. However, with European tires, you might get like 10% of the tires, end-of-life tires, you might get cord. And then the question is, what kind of cord is it? It could be polyester or polyamide, or it could be this highly reinforcing, what's the brand name again? Aramid. That's a brand name for Teijin. I think there's other brand names, Kevlar or something like that. Also depends again on the type of tire you put in. If you pyrolyze airplane tires, they consist like half of an airplane tire is textiles to reinforce. When you see the airplane landing, actually they're leaving a lot of rubber on the runway. So there's a lot of tire in there. Some markets could be non-wovens, that you aggregate those fibers and you make actually you make products that could be, for example, for construction, automotive, insulation. On the inside of the wheelhouse of cars, they use this kind of thing, and they use recycled textiles. So that would be one application. House wrap could be another. Where you have a non-woven, where you aggregate those fibers and use, you make like mats for insulation. Clearly, on the higher end value, if you are, in a collaboration with companies like Teijin, you can take out the high value fibers. They're very interested to start a circularity. Maybe the other fibers, they're not so interesting. Polyester, polyamide is not that high value. But they're really interested to dig out the aramid fibers out of the general fibers. And again, both the fiber amount and the type of the fiber will depend on the region and the type of tires you're recycling.
What about the recovered carbon black quality from conveyor belts?
I don't have firm data, meaning for me as an engineer, data would mean I have numbers and composition. But honestly, I would regard a conveyor belt, and in mining regions, you have mainly mining tires and conveyor belts. My understanding of a mining conveyor belt, it is a tire. You have a tread on the outside, which is protecting, tear resistance, scratch resistance, all that from the rocks that are transported with that conveyor. Then you will have a carcass type, you will have belts, you will have plies. So we have all the interiors you have with tires as well. And you will have more semi-reinforcing compounds on the inside. What perhaps you don't have the sidewall. The sidewall is very thin. So I would say it's pretty much the same, although I would not expect the high-end carbon blacks as in truck tires and conveyor belts. More like simple reinforcing 300 types of carbon black. But again, I cannot claim I have quantitative data, but I would say this is a nice feedstock. Although when you think RCB rubber project, Michelin and Bridgestone, they suggested to define the RCB product by the type of end-of-life tire feedstock used. And clearly, they only mentioned tires. Of course, there might be a different product, recovered carbon black, that is made from conveyor belts. I wouldn't see a problem if the performance in rubber is similar to a recovered carbon black from tire feedstock. To also call it recovered carbon black, for me, really, it's the chemical composition and not the type of the broad type of feedstock that is important. I would say it could be a nice feedstock. The problem is, I have a contact in Australia who imported about 80% of the Australian mining tires, and he developed road trains for this, huge road trains, like they have them in Australia. And he developed that to transport the conveyor belts as well, because to transport an end-of-life tire conveyor belt that is like, 1 or 2 miles, it can be quite challenging.
Do RCB producers take out tire textiles before pyrolysis?
I would say, as mentioned, there's a trend to smaller and smaller crumb.
Yeah.
Typically, when I started continuous processes like rotary kilns, they were happy with less than 20 millimeters. And in there, you would still have an amount of steel and an amount of fiber. But the smaller you go, and then you're practically eliminating all the fiber and also all of the steel. When you have like 6 millimeter, 5 millimeter, 3 millimeter granule, you can actually expect that the whole fiber is out and the whole steel is out as well.
What happens to tire textiles during pyrolysis?
Okay, this I think depends, of course, on the pyrolysis process and the temperature conditions we might have.
Yep.
I would expect under normal, typical pyrolysis temperatures, which are, for me, as I said, around 500-600 degrees, I would expect any textile, maybe apart from the aramid, any textile decomposing. Certainly polyamide will decompose and polyester will decompose as well. Polyester has a pretty high decomposition temperature, but they will go in the gas stream and then end up either in oil or gas after the condenser. What is unclear to me is like the higher end fibers of the performance tires, the aramid type of fiber. They might have a pretty high decomposition temperature, although I could imagine that, even 600 degrees will decompose that as well.
Okay.
Unless you have glass fibers, that would be different.
Yeah, of course.
But I would actually expect the whole fibers end up in the oil and gas stream rather than recovered carbon black. And there's one company, Delta Energy, who funnily mentioned in their technical or safety data sheet for the recovered carbon black that there is a content of polyester. And then you might ask yourself, well, shouldn't the polyester decompose? And they have a low temperature pyrolysis using a catalyst, and the catalyst apparently is on a matrix of polyester, which then ends up in point something percent of the recovered carbon black being polyester, which they specify in their technical data sheet. But this is, I would say, the really odd case. I would expect normal pyrolysis operations at a higher temperature than the polyester can sustain into the raw recovered carbon black.
How do you sort car tire end-of-life feedstocks?
Sorting the tires, the requirement, I was at EURIC, the European head association of all recycling associations in Europe, and there was a tire recycling day. I had only 5 minutes presentation slot. I think I only spoke 3 minutes, and I said two things. I said, really, the industry needs to collaborate on the tire sorting, because even now the companies that offer granulate, for example, like Genan, they cannot provide you out of the shelf a granulate which is of a defined composition. They will do it for you as a bespoke service, but they will have trouble doing that. So tire sorting is really key. The second thing, really, I said, we need more investment from the big companies in technology companies, because technology companies that don't operate, they don't have cash flow. And how can we expect them to develop their technology if they don't have cash flow? But back to the sorting of the tires. So the first level is just by side, by type. Of course, you could sort also by brand and different things. But really, when we're sorting with the aim of having a consistent chemical input, specifically of the inorganics into the pyrolysis. And if that is consistent, then our RCB will be consistent as well. And so really, it is separating car tires and truck tires, or to make sure that there is an amount of truck tires, let's say 10-20% always in the mix, so that the silica from the car tires doesn't weigh in too high. That is level one. And level two is if you would do an analysis of the tire, but then, it's very tedious and you cannot do an analysis of every tire. Level three, and this is actually patented by Black Bear Carbon. There is a patent called, I think, even tire sorting, where they analyze with XRD the silica content. And it's an analysis that, is pretty quick, and you can do it on a conveyor. What you need to analyze is the tread. So tire is lying on the conveyor, you analyze on the side. I think there need to be multiple analysis points, and then you determine the silica level, and then later on you do the sorting as to the silica level. And that will really be the best for giving you a chemical consistency of the recovered carbon black. So that patent is existing. I do know that Boulder Industries have included tire sorting in their patent as well, which currently is only valid for the US, and they're trying to get it valid internationally, but I think they will not manage, because now it has been taking a long time. And of course, for them, it's like a strategic advantage if they could get internationally, because then they could actually effectively block others out of sorting tires and doing a 80-20 mix of car tires and truck tires. Although I would argue, I've been talking about mixing tires and sorting tires for a number of years, so I would be surprised, but you never know what the patent offices are able to accept. Sometimes looking at the patents, I'm looking at like, wow, how could the patent office accept that kind of patent that is already known to the industry, that is like a prior art in patent speak. Yeah, that could be like a bad surprise for people in Europe if the Boulder patent will go through in Europe, because then all European companies would have to pay license fees to Boulder. Thinking one step further, integrating it into an ecosystem. Some tire companies like Michelin and Bridgestone realize they cannot expect at present from a tire pyrolysis company that they only recycle Michelin or Bridgestone tires. So they accept it's a mix of tires. Bridgestone case just say, we want to recycle all the tires, or we don't want only our brand, but we want to recycle all the tires to the amount of our production. Other companies, and I think Pirelli is going that way, if they could, they would actually love to only recycle Pirelli tires because it's high performance tires. They know what is in there. And that is also a point I've been making in a recent LinkedIn post. The tire companies know best what is in their own tires, which enables them actually, when you think about it, they could recycle the tires much better, knowing what is in the tire. On the Zurich, we had a big heated discussion. We had many heated discussions, but one was about RFID, which is like a little metal antenna with a chip that is placed in the tires. Many people, including me, say, but before the pyrolysis, we have to get it out. Otherwise, we put electronic waste into the pyrolysis, and then the silicon chips of the electronic end up in the RCB. Then we mill it with a jet mill, and it becomes crystalline respirable silica because we mill below 10 micron D97, and that will be a problem. And also, many people, including me, we would see other ways of knowing what is in the tire. Like we need a database. The tire companies obviously have to share. They would have to share the silica content if you want to do that, so that we can sort the tires. And that will really help the industry recycle and sort tires and create a very consistent product. Michelin would say very stable. They talk about the stability. When I talk about consistency, that's what a tire maker wants. They want a stable, consistent product. And I think it would be fair to expect from the tire industry that they help us doing that, getting that consistency and stability by providing data.
Are tire pyrolysis companies working on chemicals from tire pyrolysis oil?
So, the more specialized you go, of course, the higher your R&D spend for realizing that is, and the higher your capex spend is, because you need a little distillery. And the easy answer is you don't need to do it, because I think you need a minimum specification for the oil, and including sulfur, including halogens, including solid matter. There should be no solid matter in the oil. The oil should not be black. It should be, like honey or yellow color. So that is important. Clearly, if you split and have your own distillation, your own reboiler and fractioning, you're creating higher value streams. And then clearly you get better prices for those split streams because they are purer. They're not a mixed bag. But also clearly to say it's a lot of effort for recycling technology providers like you and like other gentlemen in the webinar. And it's very easy for BASF because they can do everything. Actually, they can accept any shit, putting it into the big soup. They can take out the sulfur. They can take out everything. They can fraction. They can hydrotreat. They have all the capabilities. However, they will not pay a good price for such a low quality product. Think about it. Much of that business is driven by the mass balance approach. So they have an ocean, and they put in 3 drops of tire pyrolysis oil in the ocean, and then they're entitled to take 3 drops out which are sustainable, that are not the same drops. And that's the principle of the mass balance principle. I love to see, actually, there's VD, a company that does outdoor gear, backpacks, outdoor pants with nylon made from tire pyrolysis oil from Pyrum. But it's not actually based on that oil, it's based on the mass balance principle. So that nylon is still fossil nylon, but it is attributed, the green attributes that were put in. And that is, the mass balance approach makes sense wherever the sustainable feedstock is so small that you don't have enough volume to do a pure production just on that stream. The same counts for the carbon black oil. Carbon black oil, I would say caution, because really we've seen in the black cycle ecosystem where there is institutes and refineries developing that kind of application, and clearly they need to refine, because only the bottom heavy fraction that is very dense, a density over 1, so more than 1,000 kilograms per meter cube density is required for a carbon black feedstock oil. It needs to be very aromatic, which is good because tire pyrolysis oil is very aromatic, but it has this light fraction, which makes a very low flash point. So that needs to be taken off for the transport. That makes it easy to take to transport the oil. But then if you have like 3 fractions, you take off the very light fraction, thereby increasing the flash point for transport, and then you have a light oil and heavy oil that would optimize your revenue stream. And the heavy oil, you can look at where you do the cut, but the heavy oil could be carbon black feedstock. But that's really super heavy oil, because the model fuel, not the model fuel, the model feedstock for carbon black is anthracene oil. Anthracene is a polycyclic aromatic hydrocarbon, PAH, with 3 rings attached to each other in one. That would be the ideal feedstock if carbon black makers could only have anthracene. And it is so thick that it needs to be heated to be liquid. It will go solid if the temperatures, in winter, if the temperatures are cold. And then when you keep that in mind, the carbon black industry, it is fair to ask them to take both recovered carbon black and the oil feedstock, especially when you consider that for the circular carbon black from the tire pyrolysis oil, for 1 ton of circular furnace carbon black, you have 4 tons of recovered carbon black that the pyrolysis company needs to sell. So, and I think it would be fair that carbon black companies realize that kind of mass balance and take in 4 tons recovered carbon black for every ton they produce of the circular furnace carbon black. And then, of course, the furnace carbon black, you would produce hard blacks, 300, 200, 100 type, because clearly to separate the performance from the recovered carbon black. And that was nice. Yesterday, I had the live stream with Cabot. Cabot has introduced a 234 ASTM grade from tire pyrolysis oil with a mass balance. And then on the recovered carbon black, they've introduced a 500 ASTM, so highly structured, semi-reinforcing carbon black with 10% recovered carbon black. Also, the 500 is very difficult to reach for a recovered carbon black. So they have chosen 2 products, which I found interesting. They've chosen 2 products which don't compete with pure RCB, which is, smart in a way. So they're not eating into their own business. Thank you for joining the webinar. Also, thank you for joining the Zoom rather than the website. And so let's keep in touch, and hope to see you and speak to you very soon.